In example 6, something we see on the bottom is an I. But before I go there, I'd like to kind of read what I wrote up here. It says, just like you cannot leave a radical, and when I say a radical, I mean like a square root. Just like you can't leave a radical in the denominator, you cannot leave an I in the denominator. Now, why can't you leave an I in the denominator? The answer is because I really is a square root. Okay? So we're going to look at 6 and 7. There's one type of problem, but when we get to problems like 17 and 18, they're going to be a whole different type of problem. And we'll discuss why once we get there. Let's start at number 6, and let's please identify that bottom. Do you see the bottom or the denominator? This is how you're going to handle it if your denominator is a monomial. If your denominator, in other words, there's no plus and minus in your denominator, it's just like one term, like 3 times I. Well, what aren't you supposed to have in the denominator? The I, right? The 3 is fine, it's just the I that we need to get rid of. So in order to get rid of it, we multiply top and bottom by what we want to see go away. I over I. 2 times I makes 2I, and 3I times I makes 3I squared. Now we haven't technically changed our problem because multiplying by I over I is like multiplying by 1, because I over I is 1. So we're not changing the problem, we're just making it easier to work with. Now you might say, hey, that didn't get rid of the I on the bottom, in fact it just gave you more. But didn't we just learn on the last page that I squared is actually negative 1? So I take away the I squared and I make it negative 1. That gives me 2I over 3 times negative 1. That gives me 2I over negative 3. And yes, I'm taking more steps than probably what I typically would. And that negative comes out. It can go on top or out in front. That's negative 2I over 3. And that's how this big word is called rationalizing. I'm just going to put rationalize on the top. When you get to Miss Miles, she's going to want you to know what it means to rationalize. And what does it mean to rationalize? It means get rid of the square root on the bottom. Number 7. Well, the first thing I'm going to have you do is rewrite this as 6I square roots of 2. I pulled out the negative, but I pulled out the negative and it became an I. Okay? Do that step first. Now in this problem, I have to multiply again by what I don't want. I am not allowed to have the I in the bottom, nor am I allowed to have the square root of 2. Well, that means I have to multiply by I and the square root of 2 over I and the square root of 2. The top, we apply the rule inside with inside, outside with outside. So I do 6 times I, that's on the outside, and the square root of 2 is just kind of chilling out. The top is allowed to have an I and a square root. On the bottom, I do I times I and get I squared. I do the square root of 2 times the square root of 2 and get the square root of 4. The top does not reduce, but the bottom will become a negative 1 from the I squared and a 2 from the square root of 4. If you want to draw arrows, that's where those came from. Let's keep on going. That's 6I square roots of 2 over negative 2 when you put your denominator together. Okay, we're going to pull that negative out in front. And 6 over 2 reduces to a 3I on the top. In other words, the 2 kind of cancels out. Some students will try to cancel out these 2's. Those 2's can't cancel because that one's inside and that one's outside. Let's take a look. Caution, you cannot use the rule if you have a square root of something times the square root of something else and just multiply those things together if a and b are both negative. You must express these radicals as imaginary first. There we go. Okay? So let's take a look at example 8. It would be really bad of you to just multiply those as you see those right now and make it the square root of 100. What you want to do first is you want to make each one imaginary. For example, the square root of 4 is 2, with the negative makes it 2i. The square root of 25 is 5, with the negative makes it 5i. Now we can multiply. I'm going to make a note to myself that you can't make that the square root of positive 100. That's not allowed. 2 times 5 is 10. I times I is I squared. And you need to promise me you'll never leave I squared in your answer. So it's 10 times negative 1. That's what I squared is, which is equal to negative 10. Okay, let's do number 9. Paper a little bit. Okay, so these ones aren't quite as pretty as the last one. I can't pull any numbers out, just the I. So I get I squared to 6y times I square root of 2y. Okay, now here's our rule. We're going to multiply the outsides together. So I times I makes I squared. We're going to multiply the insides together. 6 times 2 makes 12. Y and y makes y squared. And now we're going to simplify some stuff that we know. We know I squared is negative 1. And for 12, I know 12 is made up of 4 and 3. I take the square root of 4, and I get 2. And I have y squared, and the square root of y squared is y. Please do not forget that we still have the square root of 3 left over. My final answer is negative 2 with the y and the square root of 3 left over. Let's move on to example 10. We're going to deal with complex numbers now. Complex numbers are different than, what did we learn before? Let's see. On the other page, I taught you about pure imaginary numbers. There they are, right before example 1. So we talked about pure imaginary numbers. Now we're going to talk about complex numbers. This is when we have a real number, like something that doesn't have an I, and a pure imaginary number together. You're just going to like kind of combine your like terms. It's not any harder than like adding like regular numbers and then numbers that have x's. So you see your addition sign, you're simply going to combine your like terms. So if you want to write it without the parentheses, you can. Since it has a plus sign, it just means put your stuff together. 3 and 4 make 7. See how those are similar to each other? And then 6 minus 2 is 4i. It's really, guys, it's that easy. Let's look at 11. Now on number 11, the only trick, and it actually doesn't have anything to do with imaginary numbers, the only trick is you have to distribute your negative. So we get 3 plus 6i minus 4 plus 2i. That's not that bad. You guys can do that. Distribute your negative. 3 minus 4 is a negative 1. 6 plus 2 is a positive 8i. Again, that's really all there is to it. And then let's do one more. Number 12, I made it a little more difficult. I just put 3 things in there. They're all plus signs, so we really can totally ignore the parentheses. 4 and 3 is 7. 7 and another 4 makes 11. Negative 2 and negative 3 makes negative 5. And negative 5 and 7 makes a positive 2i. That's all there is to it. Now, up here we were talking about adding and subtracting, so if you want to kind of like put a title on, you can. Actually, I already did, didn't I? We talked about adding and subtracting them. Now we're going to talk about how to multiply them, okay? So notice everything above had like a plus sign or a minus sign in it. Now we're going to have to like multiply them. And when I say multiply them, you're probably going to think, well, isn't that just foiling? Yeah, that is what foiling is. It's just like you would do with these two here. You would do first, outer, inner, last. Well, it's the exact same thing we're going to do here, guys. Okay? 3 times 5, 3 times 2, 4 times 5, and 4 times 2. Just FOIL them together, or multiply the binomials. 2 times 5 is 15, plus 3 times 2 is 6i, plus 4i times 5 is 20i, And 4 and 2 times 2 makes 8. Don't forget this one has an I squared in it. So take a look at that. Make sure it's okay with you. Promise me you remember this is really 8 times -1. So this is actually a -8 at the end. I'm just going to kind of group it off and get rid of these because I kind of fixed them. 15 minus 8 makes the 7. And 6 and 20 makes 26i. So the hardest thing is to remember that I squared becomes a -1, and that changes your term. Other than that, it's the same as it was above. Let's try 14. Now in 14, you have to remember the rule that we talked about not too long ago. You have to pull your eyes out first. Miss Miles will tell you when you go to her class, she'll say, take your eyes out, but don't go blind. She thinks she's funny. So you take out your I and you get the square root of 7. Maybe she's funnier than me, probably. Square root of 3 minus I square roots of 7. And if you're wondering, oh, let me tell you this, because I don't want you to make a mistake that I've heard somebody say in the past. Some people think that this is a double negative here and that it becomes a positive. But you really have to be careful because you see this negative sign right here? That negative sign has nothing to do with that sign out there. That negative sign is just an I. Okay? So you have to rewrite it as an I. Now we can multiply our binomials. Square root of 3 times the square root of 3 is the square root of 9. 3. Now be careful with this. When you see these two here that I'm pointing at, it's going to be 3 square root of 3 times negative I square root of 3. Well, it's going to be a negative, and it's going to be an I on the outside. But now we have a 21 because the 3 and the 7 were inside. Let's do that with these ones here. You're going to have plus. The I is on the outside, and 7 times 3 are both inside, so I had to do plus 20. I squares of 21. And now these ones. The rule is inside with inside, outside with outside. I times I, well, I should say I times a negative I. Negative I squared, and 7 times 7, square root of 49. Now let's fix this problem up. The square root of 9 is 3. Look at these guys. They cancel each other out. One's a plus, one's a minus. Now you see this minus I squared? This is really minus -1, because I squared is -1. And the square root of 49 is a 7. Well, we can do this, guys. A -1 makes a +1 with a 7. See, all of that stuff becomes 7. I end up with 3 plus 7. Well, 3 plus 7 is just 10. So that problem really, really shrunk down just to be 10. It doesn't even have imaginaries anymore. Flipping to the back, we have 4 more to do, and I will put these 4 on a separate video.